The product property of logs. Just like with exponents, if you have the same base, you can add those exponents. The same sort of thing is true with logarithms. So I can take a log of a base of a product and I can break it up into two separate logs and add them. And these are equivalent. Consequently, I can also take two logs of the same base that are added together and rewrite that as the product of the individual ones, all as one logarithm. Here's a proof of the product property of logs. So I'm letting b to the x equal m and b to the y equal n. And I'm doing this sort of to make the proof a little bit easier. You'll see why these values were chosen as we go through the proof. Well, I can rewrite these in logarithmic form. So I can rewrite this as x equals log base b of m. So I'm just rewriting it in logarithmic form. And the same is true here. Y is equal to log base b of n. So these are equivalent statements. This one's just written in logarithms. So I can multiply these two together, b to the x times b to the y, and I know that gives me m times n. So that's just multiplying these two together, and since they're equal, it equals m times n. Now using those properties of exponents that we know, I can rewrite this as b to the x plus y, just adding those exponents. And that's still equal to m times n. That's just multiplying powers. So now I can take the log of both sides. And really what I'm doing is saying that if I take the log of something, it has to be equal to the log of whatever it was equal to before. If these two things are equal, then the log of them is equal as well. And I chose this b on purpose because I can see that it matches the b up here. So this is the equality property for logs. And then what I can do is I know that the exponent is the inverse of the logarithm. So right here I have a base the same as what I'm taking the log of. So that's just going to give me x plus y. I'm undoing the logarithm by taking it to a power. So that just equals x plus y. Here I just left that the same. They're inverse functions of each other. So then x is equal to log base b of m, and y is equal to log base b of n. So I'm just substituting my value for x and for y in the logarithmic form. And that's equal to, I left this side the same, m times n. So just using substitution here for x and here for y. And so that way I can take the product of any logarithm and break it up into the sum of those separate factors, taking the log of them.